Before humans could ever dream of walking on the moon, they had to learn how to survive in space, not just for minutes or hours, but for days. They had to learn how to move through the void, to dock with other spacecraft, to work outside their capsules in the hostile emptiness beyond Earth's atmosphere. These were not small problems. They were enormous, complex, and deeply dangerous challenges that stood between humanity and its greatest ambition. Project Gemini was the program built to solve them. Positioned between the pioneering Mercury missions and the legendary Apollo program, Gemini was the critical middle chapter in America's race to the moon. It was the training ground, the proving ground, and in many ways, the most technically ambitious space program the United States had ever attempted at that point in history. Without Gemini, Apollo would have been impossible. Without Gemini, the moon landing would have remained a dream rather than a reality. The story of Gemini is the story of engineers, astronauts, and mission controllers pushing themselves and their technology to the absolute edge of what was possible, all in the name of a goal that seemed almost impossibly far away. To understand why Gemini existed, you have to understand the pressure the United States was under in the early 1960s. The Soviet Union had launched Sputnik in 1957, sent the first human into space with Yuri Gagarin in April of 1961, and seemed to be winning every milestone in the space race with alarming consistency. President John F. Kennedy responded in May of 1961 with his historic challenge to land a man on the moon before the end of the decade. That speech transformed NASA overnight. Suddenly, the agency was not just exploring space at a measured pace. It was racing against a geopolitical rival with the entire world watching. Project Mercury had proven that Americans could survive in space, but its capsules were small, its missions short, and its capabilities limited. A single astronaut could orbit Earth for a few hours or a day, but that was nowhere near enough to prepare for a lunar mission. NASA needed a bridge program, something that could develop the techniques and technologies required for Apollo while also training a new generation of astronauts. That bridge became Project Gemini, officially approved in December of 1961 and named after the constellation of the Twins, a fitting name for a spacecraft designed to carry 2 astronauts instead of 1. The Gemini spacecraft was a remarkable piece of engineering for its time. Significantly larger than the Mercury capsule, it was designed to carry 2 crew members and support missions lasting up to 2 weeks. The capsule itself was divided into 2 main sections: the re-entry module, where the crew sat, and the adapter module, which housed the propulsion systems and equipment needed for orbital maneuvering. One of the most significant advances in the Gemini design was its onboard propulsion system, which gave astronauts the ability to change their orbital altitude and direction. This capability, called orbital maneuvering, was absolutely essential for rendezvous and docking operations. The spacecraft was launched atop the Titan II rocket, a powerful and reliable launch vehicle that had originally been developed as an intercontinental ballistic missile. The Titan II was chosen because it produced enough thrust to lift the heavier Gemini capsule into orbit, while also being considered sufficiently reliable for human spaceflight. The spacecraft also featured ejection seats rather than the escape tower used in Mercury, a design choice that reflected the different risk profile of the Titan II rocket. Every component of the Gemini spacecraft was designed with the specific goals of the program in mind, making it one of the most purpose-built vehicles in the history of human spaceflight. Between April of 1964 and November of 1966, NASA conducted 12 Gemini missions, including 2 unmanned test flights and 10 crewed missions. Each mission built upon the last, steadily expanding the boundaries of what American astronauts could do in space. Gemini 3, the first crewed mission, launched in March of 1965 with Gus Grissom and John Young aboard. It was the first time an American spacecraft performed orbital maneuvers, a modest but critical step forward. Then came Gemini 4 in June of 1965, which carried Ed White on the first American spacewalk, known formally as an extravehicular activity. White floated freely outside the spacecraft for 23 minutes, becoming the first American to walk in space. The images of White drifting above Earth, tethered to his capsule against the backdrop of the blue planet below, became some of the most iconic photographs of the entire space age. Gemini 5, launched in August of 1965, pushed endurance boundaries by keeping Gordon Cooper and Pete Conrad in orbit for 8 days, proving that the human body could survive the duration of a lunar mission. Gemini 7, launched in December of 1965, extended that record to 14 days with Frank Borman and Jim Lovell aboard, while simultaneously serving as the target vehicle for Gemini 6, which achieved the first rendezvous between two crewed spacecraft in history. Gemini 8, in March of 1966, accomplished the first docking between a crewed spacecraft and an unmanned target vehicle, though the mission was cut short by a dangerous thruster malfunction that sent the capsule into a violent spin. Neil Armstrong and David Scott managed to stabilize the spacecraft and return safely, a testament to the training and composure of Gemini astronauts. Later missions refined spacewalking techniques, practiced docking procedures, and conducted scientific experiments, each one adding another essential piece to the puzzle that Apollo would eventually complete. Behind every mission was a team of human beings who dedicated years of their lives to making it work. The Gemini astronaut corps included some of the most legendary names in the history of space exploration. Neil Armstrong, Buzz Aldrin, Jim Lovell, John Young, and many others flew Gemini missions before going on to Apollo. For these men, Gemini was not just a job, it was an education. They learned how to operate complex spacecraft under pressure, how to troubleshoot problems in real time, and how to work as a team in an environment where a single mistake could be fatal. The flight controllers at Mission Control in Houston were equally vital. Under the leadership of figures like Chris Kraft and Gene Kranz, they developed the procedures, communication protocols, and decision-making frameworks that would define human spaceflight for decades. The engineers and technicians who built and maintained the spacecraft worked around the clock, solving problems that had never been encountered before because no one had ever tried to do these things before. Gemini was a program built on human ingenuity, determination, and an almost reckless willingness to attempt the impossible. When the last Gemini mission, Gemini 12, splashed down in November of 1966, NASA had accomplished something extraordinary. In just over 2 years of crewed missions, the program had demonstrated long-duration spaceflight, orbital rendezvous, docking, and spacewalking. Every major technical requirement for a lunar mission had been tested, refined, and proven. The lessons learned from Gemini directly shaped the design and operations of the Apollo program. The rendezvous techniques developed during Gemini were used to bring the lunar module back to the command module after landing on the Moon. The endurance data collected during long-duration Gemini missions informed the life support systems used in Apollo. The training and experience gained by Gemini astronauts made them the most capable human spaceflight crew in the world when Apollo began. Beyond its direct contribution to Apollo, Gemini also established the operational culture of NASA's human spaceflight program. The emphasis on rigorous training, detailed mission planning, and real-time problem-solving that defined Gemini became the foundation of everything that followed. In a very real sense, every human spaceflight mission since Gemini has been built on the knowledge and experience that program generated. Project Gemini may not carry the same cultural weight as Apollo 11 or the emotional resonance of the first Mercury flights, but its importance to the history of human spaceflight cannot be overstated. It was the program that taught humanity how to live and work in space, and in doing so, it made the Moon not just a destination, but a place that human beings could actually reach.